Today's session, we are going to see that introduction to VLSI, structure of the Verilog HDL and its modeling. In the introduction to VLSI, first we have to know about the what is VLSI. Very large scale integration is the process of creating an integrated circuit by combining thousands of trillions of transistors into a single chip. The best example in our mobile phone. That is the best example for the VLSI. VLSI began in the 1970s when complex semiconductor was being developed. Electronic design automation tools were developed to make the final product of the VLSI chip. Basically, we can classify the VLSI into two ways. One is FPGA, another one ASIC. In the FPGA, it's a kind of hard chip we can purchase from the market and we can utilize for our application. The best example, suppose we want to buy a car, then we can just go to the showroom and we can purchase the car. But at the same time, we cannot alter interior designs. Say for example, engine as well as car seater, number of car seater, all are related with the one when they are manufacturing, they have decided all those things. In the ASIC, suppose it is starting from the scratch. It is application specific integrated circuit. This chip can be used only for the particular applications. So the meaning is, I want to purchase a car means from the scratch I will develop till the end. Okay. So basically there are certain things are common and certain things are different for the ASIC as well as the FPGA. In the common, for the VLSI design, FPGA as well as ASIC using the electronic design automation tools they are using. Okay, it is referred to as an electronic computer aided design. It's a software tool to design electronic circuits. The software tool generally consists of a design flow to design and analyze the electronic circuit. The EDA flow, that is in the FPGA, this is the primary flow actually. The first started with the design entry. Basically the design entry started with the idea which we want to do. Okay, the application which we want to do. So based on that, the design entry will be started. After that, followed by synthesis process will be there and the implementation process will be there. And finally at the end, it will be downloaded into the FPGA chip. Synthesis meaning it is just a kind of optimization. I can say optimization and allotting the pin assignments to the IO ports. Optimization, the meaning of the optimization is maybe everyone have studied that Karnaugh map in the digital circuits, right? So here the tool will do all those things. And in the verification phase, that is a function. There are two things are very important. One is functionality verification and another one is timing analysis. Functionality verification, that will verify whether the intended functionality will be completed or not. Whereas in the static timing analysis, the intended functionality will be completed on the specific time or not. Okay. So here we will do one example and we will go to the remaining. In the design entry, we need the languages. Basically, three kind of languages: Verilog HDL, VHDL and system Verilog. These three languages we will use it. HDL languages are serving to model the behavior and the structure of the digital systems at multiple level of abstraction, ranging from system level down to that of the logic gate level. The Verilog HDL, the history, is originated gateway design automation in 1985. The company was privately held at the time of Dr. Prabhu Goyal. Verilog HDL was designed by Phil Murphy, who was later to become the chief designer for Verilog XL and the first corporate fellow at Cadence Design Systems. Gateway design automation grew rapidly with the success of Verilog XL and was finally acquired by Cadence Design Systems, San Jose in 1989. VHDL, actually VHDL is the first HDL language. Okay, VHDL is named after the United States Department of Defense program that created it. The Verilog high-speed integrated circuits hardware description language. VHDL has been standardized by the Institute of Electrical and Electronics Engineers as IEEE standard 1076 since 1987. The latest version of which is IEEE standard 1076-2019. The model analog and mixed signal systems and IEEE standardized HDL based on VHDL called VHDL AMS has been developed. In the system Verilog, standardized as IEEE 1800 is a hardware description and a hardware verification language used to design model, design, simulate, test and implement electronic systems. Basically, for the VLSI design, there are two phases we can see. The primary phases. One is a design and another one is verification. So nowadays, most of the people, they are using system Verilog for verification. System Verilog is based on Verilog and some extensions, and since 2008, Verilog is now part of the same IEEE standard. It is commonly used in the semiconductor and electronic design industry as an evaluation of Verilog. So the basic structure of the Verilog that we can easily identify, we can easily understood. The primary thing is, suppose these are the chips means the IOs placed here. Okay, the functionality happen inside that. Okay, the primary thing of Verilog HDL, that is a module and the end module. These two are the first. The first line is module name, that is the syntax. In bracket we have to specify the IO signals. Okay, the IO signal direction we can specify in the next line. And wire, net modeling, these things we have to take care. And the end with the end module. Okay, there are three kind of modelings are there. One is gate level modeling, another one data flow modeling, last one is behavioral modeling. In the gate level modeling, as an example, here we are going to do that OR gate functionality. On the right side, the table is there. The table A and B both are inputs. The output have been specified here. Okay, both the 0, 0 means the output will be 0, 0, 1, that is a 1. So apart from both signals are 1, remaining all are, apart from both signals are 0, remaining all are, the output will be 1. Okay, here how we are going to specify the module name ABS. These are IOs. Okay, input A comma B, both are input signal. Output S, that is the output signal. R, that is the inbuilt primitive we are taking. Okay, this is the gate level modeling. Okay, actually gate level modeling is nothing but we are going to use the already defined primitives. That's all. Okay, now the output, how the output will be. This is the simple output from the model sim output. See here, the first all are 0 means the output will be 0. So first signal 1, second signal 0, that is A and B. The output S equal to 1. Next S equal to 1. Last signal also S equal to 1 because all the signals are 1. Next we will go to the data flow modeling. The very simple way, it's we are going to use that assign operator. So basically data flow modeling, that is used to define the concurrent applications, or else like we can say concurrent digital designs. All designs will run in parallelly. So here the keyword assign, we are going to use that S is equal to A or B. Here this R, that is an operator in the Verilog system, in the Verilog language. So in the upcoming sessions we will see that all the operator and everything's okay. So also completed with the end model. So the signal also like that. So next one is the behavioral modeling, the module OR gate ABS. So input A comma B, output is S. So reg we are declaring as a register. Always block will be used for any kind of behavioral modeling. The meaning is any kind of sequential design we have to use that always block. Okay, here A, B signal are inside the bracket. Generally we can say as this signal we call it as a sensitivity list. Okay, any one of the signal is changes, then the below number of codes will be executed. That is the meaning, we call it as a sensitivity list. Of course the ending with the end module. Okay, so the output, the corresponding output like this, see here. Okay. Bye.